All right. I think we're gonna get to talk number 2 of the day. If everybody wants to take their seat. All right. So talk number 2 is about observability. It's Christine Yen from Honeycomb. I had been put in touch with Christine because one of my coworkers, Ryan, had emailed Charity Majors, who's the founder and CEO. Christine Yen is the founder and CTO. Charity and her team had what I thought were some great ideas for talks to present here. So even though Honeycomb and Influx have some intersection of functionality, I think the approach that Honeycomb is taking is very interesting. So I'm actually very excited to have Christine presenting on observability. So, where's Christine?
Hi, I'm Christine, and today I want to talk about how observability can be so much more than just this umbrella term for ops and SREs to prevent outages. Instead, I want to set all of that aside and instead talk about the other side, how observability can be folded into every stage of the development process before something is marked ready to ship, ready for production, good to go. I'm also co-founder at Honeycomb. Thank you, Paul. Thank you, Paul. And we're focused on empowering engineering teams to understand their software in production. And as a disclaimer, while I'll be sharing some examples of how we use Honeycomb to dog food as a case study today, the philosophies and techniques are generally applicable, so they should be transferable to your existing tools and processes. Sorry. So, what do I really mean by observability then? And how do we define this development process that we're folding things into? Well, there's a Wikipedia definition, which goes on for about 1,000 other words. There are the many, many opinions on Twitter, which helpfully also include arguments about whether we need this word at all and who came up with it first. For the purposes of this talk, let's talk about observability as whatever our preferred technique is, metrics, logging, events, carrier pigeons, whatever, for figuring out what the heck is happening with our code. What is going on, what's it doing, and why? As for the development process, first step, typically, well, what needs to be built? What are we doing? What needs to be fixed? PM sympathists in the audience might recognize this as gathering requirements. Next, figure out how we're going to build the darn thing and build it. This designing, planning stage. And finally, we want to make sure that the thing that we built works. Traditionally, this is done with tests, benchmarks, or manual QA. But it's a little bit of an oversimplification to call development done at this point, isn't it? Tests and benchmarks are important, but they're not enough. They're isolated, they're dependent on someone being like, this needs to be a test case. And typically they're run before things are out in the wild. And exceptions are reliable signal that something exceptional has happened in production are also limited, because sometimes bad behavior doesn't cause exceptions, it just increases lag or consumes more resources than it should. And those can be just as exceptional if you let that behavior go on long enough and compound. So let's call this verifying on my machine. And let's think about what goes on after this. Right? The development process never ends here. It's not enough for tests to pass. We responsible software developers don't just consider ourselves done when we've taken our code, thrown it over the wall, or merged to master and hit deploy. So let's extend this process to also include verifying it in production, making sure that once it's shipped, the code is doing what it's supposed to do, but not on my machine. Because we know we can't test everything, we can't catch everything in the testing or CI phase. And then we make sure that we're able to keep an eye on things, to make sure that the code we wrote a while back keeps working on an ongoing basis. And some folks think of instrumentation and observability as something that happens after you've built a thing, feeding information back into that first stage. They tend to think of tools like uptime alerts, CPU graphs, or again, exception trackers. But I want to challenge that, because the development process is so much more than those first 3 stages. Sorry. Development process is so much more than those first 3 stages. We have to care about what happens in the wild when our code meets real user workloads. We have to care about what and how our code does in production. And being able to consult that real production data to answer questions about your system using data can inform every stage of the process, not just the first. Observability should be a core part of the development process as the software is being built, not as it's being evaluated for reliability or right before it's being deployed. We need to be feeding useful information into each step of that process. As much as testing or documentation, I rolled out observability-driven development as the title of this talk. Thank you. Understanding what our code does in production teaches us how to build better software all the time. Observability isn't just for finding out when things are broken or going wrong. It's for understanding what is happening all the time. And understanding your software takes lots of different forms. And it impacts both ops teams and developers. These are classic questions, although the second one is also classically difficult to figure out the hows and whys once you get to a yes/no answer. But it's also about understanding what your software is doing from a single host's perspective or a single customer's perspective. Observability can sometimes be about predicting the future, helping us figure out whether our choices are likely to be good ones and how good those good choices might be. And observability is about helping folks define a vocabulary that ops folks and devs need to share. Normal means something different to everyone. You might freak out at the number of errors being thrown or being spat out in the logs, and I might know that those errors are fine and a red herring, and we'll clean them up later, but for now it's okay. Sometimes normal means including outliers to understand what's happening from a bird's eye view. And sometimes it means being able to exclude those outliers that you know are being turned down or temporary, and to be able to focus on everyone else. And knowing what normal means establishes a solid baseline upon which to build something new. So observability isn't just for ops. Just like the dev cycle doesn't end when you hit deploy. Part of owning our code should be constantly using data to iteratively improve it. But the current landscape out there of tools tend to feel biased towards ops folks, folks who hang out and think about systems at one layer of abstraction away from the folks actually writing the software, often causing a lot of the problems. And yes, CPU graphs and memory utilization and disk usage are important and useful, but they don't help me figure out which build introduced the issue or which special case in the code was triggered. And as developers, we need to start demanding that our graphs and this underlying data have enough richness for me to track a problem back to the code that actually caused it. Observability matters to the whole stack, to all folks involved in delivering software. And we developers need to start baking it into our day-to-day. So why does this matter so much to me? We've been leaning really hard into this model for a while now, and it's been wonderful. And while I can't tell you what to do, despite the mic, despite the stage, I can still talk about how great it's been for us to practice what we preach and what it looks like to build this culture of asking questions as we write code. To provide some context on why this matters so much, let me tell you a little bit of the code that Honeycomb runs and the sorts of things that we worry about. We ingest lots of structured data and then offer a highly performant query engine on top for folks to pull stats, analyze their data quickly and flexibly in real time. That means that we care a lot about the answers to questions like these. How's our load? Is it spread? Are we in for some Kafka rebalancing? I mean, pain. Did latency increase? We made some change to how batches come in. How did that impact performance? And finally, things like, hey, we made some changes to our memory management and our query engine. Can we handle more queries simultaneously now? Can we handle fewer? How did that change with the code that we pushed? But since we're a SaaS platform, and because we sell to businesses who rely on us to understand their systems, we have a lot of different workloads coming in, each of which we have to understand in isolation from the rest. And so whenever we're thinking about drilling down, about understanding one segment of our traffic from another, we talk about customers, which means that these questions turn into questions like, how's our load? Are our customers spread across partitions? Did latency increase? Who was impacted? Who benefited? And sure, okay, query capacity supposedly increased. How did it impact folks with a particular type of payload? Being able to tie these sorts of concerns, same sorts of concerns, hopefully responsible systems, any responsible systems engineer might have, to these characteristics that are also relevant to our business has been game-changing. And your nouns might be different. Instead of customers, you might care about individual expensive Mongo queries, or high-value shopping carts, or the countries responsible for processing transactions. I don't know. But the premise is the same, that the most painful problems to debug, the most annoying things to realize, and the things that can be most benefited by having a paper trail to help track down the problem often originate from that one outlier doing something unexpected. So we hold ourselves to a higher standard of understanding the code that we ship. It means that the folks who are intimately familiar with the code, the logic, the expected experience for different customers are also constantly checking those assumptions against reality as we're building the product. And we all need to be able to get used to exploring and poking and iterating, because the world has gotten crazy and unpredictable, and we have containers and schedulers and pods and all these sorts of things that we need to be able to tease these streams of data apart. We can't just rely on what past us decided to immortalize in test cases or put in dashboards on the wall. Let's zoom in a little closer. What do examples of what we've done at Honeycomb look like, and why am I so convinced it's better? So we think about observability, about validating our hypotheses against evidence in production, about as much as we do testing or documentation. And we write a lot of tests, and we write a lot of documentation. We all need to turn ourselves from people who think about sprinkling in some instrumentation right before we ship into folks who obsessively fold data into every step of a development process. All right, story time. This is a step where we're wondering what to fix, what to build. I think this is actually the most boring case for this scenario, because there's no shortage of people or software or talking heads telling developers what needs to be fixed. Alerts, exceptions, Twitter folks, they all help identify what work needs to be done. But data comes into play when refining that directive, when you're going from a high level, hey, your latency is elevated, to X part of your system is misbehaving under Y circumstances. This is going to be a recurring theme in these stories, but we care a lot about query performance. And because we aggregate on the read path, we pay a lot of attention to what changes we make affect that aggregation, that read performance. So we're constantly looking at things like individual leads in the query tree to understand things like, this one data set seems to pop up consistently in slow queries. Why? Which of their queries are slow? What do those queries look like? And what is it hitting along the code path? Yes, we've built up an intuition for it. We know what the code we wrote is supposed to be doing. But when it's fast and easy and quick to slice our overall query engine dog food data set down to this customer, break down by that query shape, and then look at the performance characteristics, then we have the ability to constantly be reinforcing and reevaluating that intuition against data. And that lets us help see necessary performance changes as they're coming down the road before they actively become a problem. This almost feels, when you step back, like a business intelligence mindset. This like, I'm just going to explore for the heck of it and draw up a report about what needs to be done. But when you need to validate a customer report on the fly, or you need to identify what's common about the queries that are taking the system down, being able to break down by these very fine-grained, high-cardinality fields, like customer or query, is essential to us. When we're wondering how to make the change, what to build, what actually that solution looks like, there's a difference between knowing that something should be changed or built and knowing how to do it. Understanding the potential impact of a change we're making, especially something that will have a direct, obvious impact on users, lets us bring data into that decision-making process. By learning about what normal is, or at least what reality is, forget normal, we can figure out whether our fix is actually a fix or not. Early on in our product, we had some folks ask for us to unroll their JSON for them. They wanted to send us nested deep JSON objects, and we're hoping we would flatten the JSON for them automatically. Seemed like a pretty straightforward win. Had definitely been something we'd meant to do all along and just hadn't gotten to. But instead of kind of charging off and writing that code, just to be safe, we wanted to verify how many current customers would benefit from this. How many current customers would be impacted in a way where that benefit is actually a downside. So we added some fields to our dog food payloads for things like whether the payload contained nested JSON, how deep it went, and how many columns, how much expansion would result from unrolling. And as it turned out, while we had a very small number of customers actually sending us nested JSON, or else we probably would have heard about this sooner, those customers made up a disproportionately large part of our traffic. And on top of that, a couple of those customers would have ended up with nasty schemas with like hundreds of additional columns because they just had JSON blobs they wanted to send us and be kept as JSON strings. So in the end, we made nested JSON opt-in to limit the impact after having reevaluated our view of reality. Another shorter version of this is an example of using observability to help us write less code. We keep a close eye on query latency. One of our engineers was poking around our web apps data set. He pulled up the 10th, 25th, 50th, 75th, and 90th percentiles of our round-trip query time from the client's perspective. And this is something we just happened to have instrumented. He was able to filter out some of the noise that was unrelated to this round-trip client perspective. And he realized that the median query time was less than half of our active JavaScript poll interval, which meant that instead of having to spend more time query optimization, allocating resources over there, we could make Honeycomb immediately feel speedier by just changing the client code, by just changing the polling interval. And I love these stories because they're almost like debug statements in your data. By having this flow where it's so lightweight and natural for our software developers to add these diagnostics, we're suddenly able to describe the execution of our code in the wild. We can make more informed decisions and deliver better experiences to our customers. When we're wondering whether our change works, testing your code for correctness, again, all well and good. But the real test is how well it works against live data. But what do we do when we're not actually quite sure that our change will work? Or we want to make sure that its impact is minimized, that it does the right thing, that there aren't some gremlins in the pipes. We love feature flags for essentially letting us test in production while we're still making sure that the change is one that we're happy shipping. Pairing feature flags with our observability tooling lets us get incredibly fine-grained visibility into our code's impact. This means that something that the software developers can turn on and then feed into the dog food cluster lets us be able to look at these top-level, high-level metrics segmented by things that we can tweak completely independent of how we're actually collecting those metrics. So this becomes incredibly powerful when we turn on, say, a feature flag for a very small amount of traffic, while still retaining the ability to break down by node, customer, query ID, whatever. A few months ago, we were working on a change to our string storage format so that it would be a lot more forgiving for large strings. And it was a pretty dramatic change that we weren't quite ready to roll out everywhere. We'd want to watch pretty closely for changes to performance or data integrity issues. And because it was something that was, again, it was like a request that was fairly customer-driven, we weren't quite comfortable with something like rolling it out to one node. Instead, we wanted to isolate it to that one customer that asked for it that was like, yep, sure, I'm willing to get the beta code. And we also knew it would be something that would impact certain customers when we rolled it out eventually, more than others, right? String-heavy data sets. So using feature flags in Honeycomb, we were able to roll out the change first to one data set spread across many nodes, then a few data sets also spread out, then 20. And we could still watch the performance change and make sure that those changes were within expectations all throughout, all as we were kind of dialing this knob up in a completely different system. And the best part about this approach is the ability for your developers to define these essentially ephemeral segments of your data, because your feature flags are only as long-lived as they need to be, right? We can define these ephemeral segments and answer these ephemeral questions that we have that come up during development. At this point, we actually send all live feature flags and their values along with all payloads to our storage engine dataset, so that as we observe future experiments, as we make further changes, we don't have to stop first and remember to add the feature flag to a metric name or a dashboard. They're just all right there, mapped to the flags that we as software developers are already thinking about. And when you're wondering whether this fix that you've pushed will keep working, I almost left this stage out of the deck, like just kind of glossed over it, figuring you all know how to do this, that's why you're here. But I want to press on this, because it's a great example of this ops developer split that I touched on earlier. What's the biggest source of chaos in systems? Humans, software developers, us pushing code, pushing changes. And our tools have to be able to reflect this chaos, or at least work with it in a way that we can still make sure our systems are stable. The grown-up version of the sort of manual canarying I touched on with feature flags is being able to compare metrics across build IDs and deploys. The state of the art for this these days sometimes seems to be like drawing a line to mark a deploy or matching timestamps against some other record. But anyone who's spent enough time deploying enough code to enough machines knows deploys aren't instantaneous. For example, we do rolling deploys of our storage nodes, and you can see the progression of the deploy happen. If the graphs were of something more interesting than count, something like a performance improvement we were rolling out, or something that fixed an error, you'd be able to confidently attribute that improvement to the build, not just some point in time that happens to be in the right ballpark. And if you think about the sorts of observability tools that software developers, application developers tend to rely on the most, because they speak our language, you think of what? Exception trackers, crash reporting tools. This workflow to associate, to generate behavior with a particular build, or rather an outdated build, are half the value of a lot of these great exception tracker tools. And if we can somehow remember to fold in some of those nouns, some of that vocabulary into our current tools, then maybe it can start to be more natural for developers to reach for this set of tools. Embedding instrumentation and observability into our day-to-day, teaching our tools to talk in terms of things that help developers debug, that's how we move developers from that part of the process over to this part, actively, reliably, addictively. By making our observability tools use the nouns that are already ingrained into our software development process. Build IDs, feature flags, customer IDs, these segments that folks are already coding against. We can map the sorts of changes in the sorts of metrics that ops people typically care about, latency, error rates, to the code we write and the releases we ship. And this ability to introspect on the fly can be huge, especially for changes to sensitive or high latency or high traffic components of our systems. By all of us learning to incorporate observability tools into our day-to-day as software engineers, we can build up the muscle memory of thinking we want to do something or we want to do something in some way, making sure we have the instrumentation there in place, querying our data to validate that hypothesis, and then acting on it. Hopefully finding out something that we thought was true is wrong and being better as a result. Developers should be looking at not just what our local test output says or what CI tells us, but also learning to rely on this lightweight, transient information captured in the wild to inform us as we're building our software. One of the questions we tend to get from folks who are like, okay, well, you're telling us to capture everything. How do we even start? Start at the edge, right? In our web app, for a long time, the least sensitive part of our system, we just stuck in middleware that turned each HTTP request into some event for logging. But that actually worked pretty great. We were able to toss it into dog food, immediately start answering things like, hey, well, I forgot to instrument this new thing I built, but I know the endpoint that's getting hit. Who's hitting it? How often? Will anyone care if I take this old thing away? On top of those standard HTTP attributes, URL, status code, latency, et cetera, we made sure to include our business-relevant characteristics, like customer ID, dataset ID, and also infrastructure characteristics, right? This is your standard host name, but also things like which Kafka partition is it going to, which Mongo replica set are you hitting? And as we found ourselves asking questions, things like, we're about to make a change to our cache, what does success look like there? We would make sure that we were capturing the information necessary to answer those questions before landing that thing. That way we'd have before and after, and better be able to understand how a change to the internal workings of a system affected those external measures. Remember, a lot of the examples I ran through earlier, nested JSON or the feature flagging storage engine, those all relied on data that we had to add as we were working on the thing. We didn't know a week before that we were going to be worrying about nested JSON. But the simpler and the smoother it is for developers to add this metadata on the fly themselves without having to go through an ops team or the owner of some cluster, the more we'll be able to use it to make sure we're building the right things. And some timers, some things we make sure to prune, nested JSON no longer there. But some fields, timers, we just leave in place in case they're useful. Things get pruned, especially if they're noisy or if they send a lot of data that we no longer need. But thinking about your data, your schema in this flexible, fluid way lets developers start to be free about adding things and not being like, oh, well, is this going to 3x my storage? Are ops people going to be mad at me? Some things that have helped us keep our data clean and easy to work with. Contextual structured data. In our API code, contextual means, in our API code, we attach a map literally to the request context and go. We pick up attributes along the way as the code is executed, and then we send the payload off on HTTP response. This ensures the collection of a lot of useful context alongside the metrics that we care about visualizing, as well as providing a really consistent mental model of request to event. Establishing a common set of nouns and being consistent with our naming patterns. Probably doesn't happen to you. All of you guys are probably great. Some of our customers end up in a pattern where they end up with app_ID and application-ID and application capital IID. Avoiding that helps future us not hate past us. Those common business relevant characteristics I mentioned, those nouns, establishing kind of a consistent set of metadata on all the events that we send makes it easier for us to look at one part of the system and look at another, be able to jump around, knowing what terms I'm looking for in each. And think about how you're likely to read that data, how important certain attributes will be relative to others, and instrument your services according to your need. I put don't be dogmatic here because we talk a lot, in some of our marketing materials, we talk a lot about how pre-aggregation is terrible, but we find, along our right path, we found ourselves in the situation of not only having a very high throughput, performance-sensitive code path that we didn't want to mess too much with, and also being less interested in the granular observability. We already learn a lot of things about individual payloads at the API layer, so along the right path in our storage engine, we're not too concerned with it. So we do actually batch up writes there, per dataset, we have lots of things that we do that aggregation against. But this helps us keep life saner for everyone while retaining the full query fidelity for everything along the read path. And just because I always like to show folks what our experience really looks like and how things actually look under the covers, this is what the schema has looked like as our own API dog food data set has evolved. First, started with these high-level fields. Who was sending us data, what that data was shaped like. Handful of timers, some useful metadata, and some instrumentation around how the code was performing. And then it just kept growing. We added more business-relevant characteristics, more timers, more metadata. Anything that could help future us find some interesting correlation, we threw in there. Pruning things that we were like, this is a short-term experiment, I'll get rid of it. But being free to toss data in and query against it later makes your data set so much more useful and so much more flexible for anyone in your company to be working against. So I don't care what tools you use. We should all be doing these things. Big or small, compliance or no compliance. The folks involved in shipping software should understand the behavior of their systems in production. Honeycomb is small. Charity and I came from Parse at Facebook. Facebook does this. If Facebook can do this, well, if Facebook can do this, Honeycomb can do this, no matter what size your company is, challenge your developers to be as responsible as ops folks are. Software developers have to own observability because we have the most to gain by understanding what the real world looks like, how our code actually behaves. We better understand what to build, how to build it, and who we're building it for. We have the power to make our users happier by building better software. And by making observability tools reflect the reality that we live in, we can be better engineers and ship better things. Thanks. Do I have time for questions? Someone make this face at me if I need to get off stage. Okay. Yeah. Sorry?
You're saying, is there time for questions? Yes, there's time for questions. No, I don't have any questions.
I'll be around all day. So if anyone thinks of anything, come grab me. I'd love to talk about your team, what you're using, what you're doing, how you're teaching folks.
Quick question on your data retention. How long, because as your schema was growing, you had a lot of dimensions in it. How long do you retain your data, and what is your typical query pattern?
So our API server, I believe we store about a week. One of the techniques that we believe in very strongly, especially as we say capture wider events, is to think about sampling your data. And when folks hear sampling, they're like, oh, well, you can't just tell me 1% of my traffic will represent the whole thing. And we say, well, it's not just 1%. You know a little bit about what events, what requests, what things are interesting and what things aren't. 200s are fine. No one needs to see every single 200 that it goes through. Show me, keep 1 out of every 100 200s. But keep every 500 or 400. Keep everything that is unusual, that will warrant someone kind of going, huh, and digging into. And that's something that we use ourselves heavily for understanding these like high-level shapes, these trends, these things where the context that Paul mentioned earlier, like the context keep hanging on to these pieces of metadata can be so much more useful than just having a complete log of everything that ever happened. Yeah. I think there's a...
Oh, thank you. Besides logging, what can a developer use to gather such data or to provide such data to this?
I'm sorry, besides logging,
what can the developer use to make this data available?
So there's a number of tools around your code in production that all typically rely on signals and machine data that your code outputs. So all the things I mentioned, feature flagging, tools like Honeycomb, tools like Influx, they all ultimately have to rely on your code outputting some sort of signal. And I don't know about Paul. I don't think of things like Influx metrics as logging. It's all just, these are the signals your systems are putting out. You need to be able to read them, and you need to be able to have a way to capture them efficiently in production. Yeah.
So part of the problem with, I think, educating engineering groups to actually utilize that instrumentation is to allow them to do this easily. And the question that I had is there any library that is like the best known thing that you can just import into your code and then just start spitting instrumentation out to in some sort of a generic way? So, and then you can just say, hey, engineering group, this is how you do it if you just include this thing. Every time you want to instrument anything, just write that one line of code. Is there anything like that?
I wish there was. A lot of the premise here is that you understand by doing, and you understand by playing, and you understand by interacting. And so the one line of code often is that just that first step, starting at the edge, right? Capture HTTP requests, turn them into something useful. But the value comes in people using that data to answer questions and being like, oh, if only I had this extra thing. And then adding that extra thing or changing something. And I think it's less about that first thing being all you need, that first line being all you need, than the second, third, or fourth changes being easy and lightweight.
So the reason I'm asking this is I started using Telegraph, and I was actually trying to encourage engineering utilizing, for example, StatsD. So making StatsD enable in Telegraph and the local machine, and then everyone could just spit whatever they want in there. But I found there's no best practice or anything that I can come and say, hey, do this and everything will be fine. Later on, you can go and observe the data, learn whatever you want. But let's start with dumping everything we can. And so I found this is a hard sell, if you will, within an engineering organization. I wish everyone would do it, but everyone needs to buy into it in order to allow this.
I want to pull on this thread with you after, but maybe not on stage. So let's talk about this more later. Yeah.
I really like how you mentioned the word. Oh, I didn't have to enunciate that loud. I really like some of the phrases you used about addictively producing metrics and helping people discover things about their applications and in systems. But what I'm interested in is, do you have any recommendations on how to analyze these correlations? How would you help somebody take this kind of data and understand it?
The thing that I think is the most natural for humans is when you're, I find myself in this situation a fair amount. I've got a clue that something's up. Some latency number looks higher than it should, or some error rate looks higher than it should, or whatever example you want. And I might have no idea where to start. the thing that, like, if you map it to any other like non-engineering, non-debugging technique, you're like searching for something in your house, right? You sort of just you start with an idea of where to begin. So, you know, my keys are in this house somewhere. You just start looking around, and you start experimenting. And I believe really strongly in tools. Again, I talk a lot about query performance. I'm sorry, but I believe really strongly in making that, like looking under a rock, fast enough to ask that question, get an answer, and learn from it. Oh, I looked under this rock. There's no correlation here. All right, in the future, I will not check this metric by host first. I'll check it by something else first. And again, like there's a lot of learning by doing, you know? And so this is why I'm harping on the make it simple and lightweight and friendly to do so that people are willing to try and people are willing to look and build up this intuition of, oh, hey, you know, typically this one clue, I should look under this rock first. You know, elevated latency, I should break down by customers first because I know that one customer typically something, and kind of spreading institutional knowledge. Again, I'll take this offline. Spreading institutional knowledge is a kind of secondary mega interest of mine that is not as relevant to this talk for now. But grab me afterwards, and I'd love to talk your ear off about this. All right. Thank you.
Is this on? There we go. Thank you very much, Christine.